We are now beginning our study of three-dimensional figures. Three-dimensional figures have length, width, and height. We also refer to them as base, depth, and height. Notice that as we studied two-dimensional area, we said area was base times height. Well, that next or that third dimension is depth, more commonly referred to as length, width, and height. And you see where they are located on this three-dimensional box, three-dimensional figure. A face is a flat surface on a three-dimensional polyhedron. An edge is the line segment where two faces meet, and a vertex is the corner where three or more edges meet. So first, let me point out the face. Now, the face is just all the flat sides. That's not showing up real well. Let me change colors here. Right here. This is a face. This is a face. This is a face. And there are also three more faces on this three-dimensional figure. One in the back, one on the left side, and one on the bottom. Now, the next thing we're going to look at is the edge. Remember, that's the line segment where two faces meet. Well, I see a face on the front and a face on the right side, which creates a line here. That line is called an edge. So every line that makes up this three-dimensional figure, every line here is an edge. And finally, we're going to talk about the vertex. The vertex is where three edges come together. So in this corner you see here, three lines came together. There's actually another, those three lines create the vertex. When we have more than one vertex, the plural form is vertices. Okay, now I want you to focus here with me on this vertex, and this vertex. All three of them, we can only see two edges coming together, which the definition says there has to be three or more edges coming together. But what we have to understand is on the back side of this three-dimensional figure that we cannot see, there would be another edge coming and meeting at that corner. Now we're going to start talking about surface area. And surface area is basically, if we look at these examples here, they're three-dimensional figures, okay, sort of boxes, I guess we could call them. But we're going to say the surface area is how much space or how much area is located on the surface of these things. So if we look at the X box, how much plastic is needed to create the cover of the X box or the camera or even the television? So that's what we're looking for. Now, surface area, the definition says the sum of the areas of all the faces. So basically what we're going to do is, remember, the face is the flat side. So we're going to find the area of every single flat side of this three-dimensional figure. And after we find the area of each of those, we're going to add them together, and that'll tell us the surface area. In this example, I have the different faces, specific colors on purpose. So do you see a red face? Of course you do. It's right in front. And so we are going to look at the front side of this box. Do we know the dimensions of this red rectangle, this red face? Well, we see pretty quickly that there is a 10-inch measurement or dimension right below that red rectangle. Well, that's going to be our base of that rectangle, but now we have to find the other measurement, which in this case, since this red rectangle has a measurement going straight up and down, that would be the height. Well, I don't see a height really quickly. I don't see it going up and down right here, so I have to look elsewhere on my picture. Do I have that measurement somewhere else? And I do up here, that 4 inches is representing that straight up and down height measurement. So it will be the same for my red rectangle, which means I now know the base and the height of the red rectangle. Those are my dimensions. So is there another red face on here? Do we see one? Well, no, we don't see it, but do we know where it is? We know that we have a red face in the front, but we also have a red face in the back. Because of what we know about three-dimensional shapes, in this case, the front and the back are the exact same. So they both share the same dimensions. If we find the area of both, we will have to multiply base times height. That's the formula for area of a rectangle. And they both, using the dimensions that were given, 10 inches by 4 inches, give us an area of 40 square inches. Let's now focus on the blue face. There's a blue face on the right side. Okay, what are those dimensions? Well, luckily for the blue face, the dimensions are right next to it. See, now, it is a rectangle, but if we look at the picture, it sort of looks like a parallelogram, and that's because it is slanted like this. But we just need to understand the only reason it's slanted is because of the view that we're looking at it. We're looking at it straight on, and that's a side piece, so it sort of creates an illusion of it being slanted. But if we were to shift our focus from the front to looking at it from the side, it would be a rectangle. And the dimensions would be 7 inches for the base of that rectangle and 4 inches for the height of that rectangle. Do you see another face, another blue face? Well, we don't see it, but we should know that it's on the left side. The left and right side have the same exact shapes, the same exact faces, with the same dimensions. So now we know by using the formula of area of a rectangle, area equals base times height, we know that the area of both of those will be 28 square inches. That's 7 by 4, which is 28. Finally, do we see the green face? Well, there's a green face on the top. Okay, on the top. What are its dimensions? Well, this can be a little bit tricky because there are no numbers directly next to the green face. So this is where we really have to focus on the different pieces. Since this goes straight across, and we know that rectangles, opposite sides are the same. Since the bottom is 10, that means the top is 10 up here. Well, that line shares the base for the rectangle and for the red rectangle and for the green rectangle. So we do know the base of the green rectangle. Now we need to look at the height, or the width, I guess, in this case, of the green rectangle. And to do that, we have to focus on this slanted measurement. That's the other side of the green rectangle. So opposite that, on the blue rectangle, we see is 7 inches, which means our dimensions are going to be 10 inches by 7 inches. Take a moment to look at that. Make sure that it makes sense to you. Is there another green face? Well, we don't see it, but there is, and it's located on the bottom. So the bottom and the top have the same shapes and same dimensions, which mean that they both have the same area. So each has an area of 70 square inches. That's 10 inches by 7 inches, which gives us an area of 70 inches. So if you think about it, we have added, or we have found the area of every single face on that three-dimensional shape, even the ones we couldn't see. And now the final step is we have to add all of the areas together. So here are all the faces that we had with their areas written inside of them. Now we just need to add all of those 6 faces together to get our surface area. So it's 40 plus 40 plus 28 plus 28 plus 70 plus 70, which gives us a grand total of 276 square inches. Now this is an area measurement. It's a surface area measurement. So our answer will remain in square inches. This is what we'll do when we find the surface area of any three-dimensional figure. We will find the area of every face and then add all of those areas together.